Question 2, part 1. You are given a graph y is equals to ax squared plus bx plus c over x plus d. Now it has its vertical asymptote as x equals to minus 2. Alright, so vertical asymptote x equals to minus 2, and the oblique asymptote cuts the x-axis at x equals to minus 2 as well. Oblique asymptote cuts the x-axis, x-axis at x equals to minus 2. Now you are asked to state the value of d as well as to show that b is equals to 4a. Now the vertical asymptote is x equals to minus 2. So what you need to do is, to find the vertical asymptote, you equate the denominator to 0. So x equals to minus d. Now, so you do a comparison, d equals to 2. Now, the other part, the oblique asymptote cuts the x-axis at x equals to minus 2. Now, how to find the oblique asymptote? Now, if you look at this equation, this expression on the right, you find that it is an improper fraction. Now, to find the oblique asymptote, you need to do a long division. Now, so what you will get is, you will get y, which is equals to ax plus b minus ad plus, now this part is here, c minus bd plus ad squared over x plus d. Now if you do a long division, you find that this part is the quotient. Alright, this is the quotient, and this part is the remainder. Now I will not bore you with the long division working, as you have already learned in Sec 4. If you have forgotten, please go and revise. Now, so you will have its oblique asymptote. Oblique asymptote will be equals to y equals to ax plus b minus ad. Now, it is given that the oblique asymptote cuts the x-axis at x equals to minus 2. That means, for this equation, y equals to 0 when x equals to minus 2. So all we need to do is we substitute x equals to minus 2 into this equation. You will get minus 2a plus b. Then this will be minus a. But d is 2, which we have found earlier. Alright, and the y will be equals to 0. So here, over here you get minus 4a, minus 2a, minus 2a, you get 4a. You bring over to the other side. So b equals to 4a. Alright, that is the relationship. Now we have come to the second part of the question, and that is the most interesting part of this question. Now you are asked to find the condition of A and C. Right? The condition of A and C such that the graph always have a positive gradient. What does that mean? That means your dy by dx is always greater than 0 for all real values of x. Alright? Now, how do we approach this? We find that y equals to ax plus b minus ad plus c minus bd plus ad squared over x plus b. Alright, we were given a graph and then we do a long division, and this is what we get. Now to find its dy dx, we just differentiate this equation, and what we get here is a. Differentiate this is 0 because this is a constant. To differentiate this, you can apply your chain rule. Over x plus d squared. This is dy dx. Now you want this to be always greater than 0. Now what is x plus d squared? X plus d squared is always greater than or equals to 0. But x does not equals to minus d. So x plus d squared is always greater than 0. So you can do a cross multiply without changing the sign of the inequality. Since x plus d squared is greater than 0, for x does not equals to minus 2. Alright, then what do you get? You got a into x plus d whole thing squared minus c plus bd minus ad squared is greater than 0. Now what do you find in part 1? We find that d is equals to 2 and b is equals to 4a. Now let's substitute these values into this expression to simplify it. You get a into x plus 2 whole thing squared minus c plus d is 2, so this is 4a into 2 minus a, and then into this, you got greater than 0. Now if we simplify this expression, what will we get? Here is 8a minus 4a, so you got 4a over here. So your expression is just simply a into x plus 2 whole thing squared minus c plus 4a, and you want this to be greater than 0. Now look at this. What kind of graph is this? This is basically a quadratic graph. Now what does this represent? This represents the y coordinates of its turning point. Now you want this to be always greater than 0. That means your graph, this quadratic graph must look something like that. You want it to be greater than 0. What is the condition? A must be greater than 0 because you want this to be a minimum graph. So your a has to be greater than 0. Now this is the minimum point. The y coordinates of the minimum point. So you want it to be above the x-axis because you want this graph to be above the x-axis. So you will have minus c plus 4a to be greater than 0. Then you have c is smaller than 4a and a is always greater than 0. So this is the condition that they are looking for. Okay, now with that we look at the other part of the question. Let's look at part 3 of the question. Now, you are given that the graph passed through 0, 0. So the graph C passed through 0, 0. Now you are asked to find the value of c. Now we know that the graph is equals to y equals to ax squared plus bx plus c over x plus d. Now this portion of the question is really straightforward. You just put x equals to 0 and y equals to 0. And then what do you get? Now you get 0 over c d. 0 equals to cd. Now so c is equals to 0. Okay, now let's look at part 4 of the question. Let's spend some time reading it. Okay, part 4, you are given that a is equals to 2. And we found out that b is equals to 8 and c equals to 0 and d equals to 2. Now you are asked to sketch the graph. So you just put these values into your equation of the graph, which will then be y. Now earlier on we have expressed this as a proper fraction. Okay, I will use that because that we can see the asymptote easy. You are given that a is equals to 2, b is equals to 8, c is equals to 0, and d is equals to 2. Now you are asked to sketch the graph. Now all you need to do is you put these values into your equation of the graph. Now earlier on we found that y is equals to ax plus b minus ad plus c minus bd plus ad squared over x plus d. All you need to do is you just substitute these values into this equation of the graph and you will get 2x plus 8 minus 4 minus 8 over 2 plus 2 into 2 squared over x plus 2. So plus here. Now you simplify this. This is 2x plus 4. Now this is minus 16 and this is 8. So you will get minus 8 over x plus 2. Now this is the, what is this? This is the oblique asymptote we have learned in question 1. Alright, this is the oblique asymptote. And the vertical asymptote will be given by x equals to minus 2. You just equate this to 0. Now we will go ahead to sketch the graph. You can key this graph into your graphical calculator and they will give you the sketch of the graph, but they will not show you the asymptotes. So the graph will look something like that. Maybe I use a different color. I use orange. Okay, you have 2x plus 4. So you have a 4 here. So 2x plus 4, it looks something, maybe I should use a dotted instead. Okay. And you have a asymptote at x equals to minus 2. So because this gradient is 2, so this is 4, this should be minus 2. Because it's slanting this way, because it's positive. So the gradient is 2, so this one will be twice of this portion. So you got minus 2 here. Now you have to name your asymptote, okay? For sketches, you need to name your asymptote. 2x plus 4, and then you have x equals to minus 2. Okay, how will your graph looks like? I shall use red. You will get closer and closer to the asymptote. Okay, whereas this one, you look at the GC, because you pass through 0, 0. Make sure you draw, you pass through 0, 0. So your graph will look something like that. All right, it's actually a curve. Okay, curve. Now, you look at the GC, all right, this, where it cuts asymptote, this will be minus 4. Okay, any question? Okay, we shall now go on to the last part of the question. Okay, now we have come to part 5 of the question. Now, part 5, they ask you to find the equation of normal at point 0, 0. All right, and they also ask where did the normal cuts the curve again. All right, normal cuts the curve again. Where? All right, so we must first find the equation of the normal. Okay, to find the equation of normal, all we need to do is we need to find the gradient first, because we are given a point. So if we know the point and the gradient, we should be able, or we definitely can find the equation of the normal. So now we are given that y, or rather we have found that y is equals to 2x plus 4 minus 8 over x plus 2. Now we can differentiate this to find the gradient of the tangent. So dy by dx, you will have 2 plus 8 over x plus 2. Now, it passed through 0, 0. So you substitute x equals to 0 into this equation. Oh, sorry, it should be a square. This is a square here. Sorry, it should be a square. There's a square. I left out the square. All right. So you substitute 0 into here. What will you get? You get 2 plus 8 over 4. And then you got 4. That is the gradient of the curve at 0, 0. Now, what is the gradient of the normal? Now, therefore, gradient of normal will be the negative reciprocal of this. All right, you have learned that in Sec 4. Gradient of normal will be equals to minus a quarter. Now, since the graph cuts through 0, 0, so your equation of normal will be y is equals to minus a quarter x. Okay. Now the last part they ask, where did this normal cuts the curve again? Now it's very simple to do the last part. All you need to do is now where it cuts again. So if the two graphs meets, all right, we can say minus a quarter x equals to 2x squared plus 8x over x plus 2. Now this is the gradient. Now this is the equation of the graph, and this is the equation of the normal. All right, you key this into the GDC. All right, y into this y equals to minus a quarter x, and y equals to this, and you can see where it intersects. And by reading the GDC, you should get something like that. But of course, in decimal form. Okay, I leave the last part, the GC part to you.